Hello, my name is Justin, and this is my multiplanar movement video assignment submission. This video will aid in defining and providing examples of common moves that clients may have to replicate in their workouts. When the shoulder joint, or glenohumeral joint, is abducted or adducted, it is moving in the frontal plane on the antero-posterior axis. Think of abduction like an alien abduction, where something is being taken away from you. In this case, your arm is being moved away from the middle of your body. Adduction is the opposite and occurs when you move a limb closer to the body. A common example of shoulder adduction occurs during jumping jacks. For example, if I were to jump, I would be abducting my arms, and if I were to bring them back down, it'd be adducting them. So abduction and adduction. The lumbar spine, which is located at the midpoint of the back of your body, can move in many ways. Here we're going to focus on lateral flexion. So flexion occurs when decreasing the angle of a joint, or in this case several smaller joints, which are the vertebrae. And lateral is a term describing the movement in the frontal plane and the antero-posterior axis. This movement occurs a lot when doing oblique exercises, so even just laying on the floor and tucking side to side is an oblique exercise. And it definitely moves the spine in a lateral way, and it's flexing each time it decreases the angle on each side. Shoulder girdle protraction occurs when moving your shoulders forward, whereas retraction occurs when moving them backwards. So again, protraction and retraction. Both these movements occur in the medial-lateral axis along the sagittal plane. Protraction often occurs in a pushing exercise. So when you're pushing, you're protracting your shoulders, and retraction often occurs in pulling exercises such as rowing. So when you're rowing, you're retracting your shoulder girdles. Knee flexion occurs when you decrease the angle at your knee joint by bending it. As an example, this would be a flexion of your knee. Knee extension occurs when you fully extend your leg to straighten it, like this. The flexion portion occurs in hamstring curls for an exercise or with a wind-up for a kick in soccer. And the extension part occurs with quadricep extensions during exercise or the follow-through with a soccer kick. And the hip joint is actually largely responsible for the way your toes point. So medial rotation occurs when your hips cause your toes to point in by rotating your legs inward, so like this. Whereas lateral rotation occurs when rotating your legs outward, like this. Both of these rotations occur along the transverse plane and on the longitudinal axis. These actions can occur during turning movements while skating. If I were to turn right, my right hip joint would be laterally rotated and my left hip joint would be medially rotated. So my left hip is pointed, So my right hip is pointed right and my left hip is also pointed right. But since one of them is being pointed away from the midline of my body and the other one is being pointed toward the midline of my body, they are different. Alright, so this is my Tensegrity model. As you can see, it has two parallel coffee stir sticks here, two parallel ones here, and then two parallel here as well. They do bend a little bit, but that is just because of the materials I used. The way it's set up is that the coffee stir sticks rely on the tension in the elastics here to maintain its shape, and they're doing that quite well. I can drop it and it will absorb the impact, the force. This is kind of how our body works with a three-dimensional aspect. So we have three planes which are kind of represented via the three pairs of parallel stir sticks, which are all at perpendicular angles to each other. So the planes are kind of representative of the three major planes that we have in our body, and the the elastics are kind of like the muscles in our body, and the stir sticks are kind of like the bones in our body. So it just depends on the amount of tensile strength that we have with our muscles, and these affect how our bones are placed. So, for example, for posture, everything needs to be in perfect balance in order for your posture to be proper and perfect, which is just the same as saying that the tensile strength in the elastics needs to be symmetrical in order for the structure to maintain its symmetry. Now I'd just like to say thank you for taking the time to watch this video, and I look forward to using this information in the future.